Hello, my name is Todd Kelly, and I'm from Purdue University. And today's topic we're going to focus on is the decision matrix. And back when our field first began to explore engineering design as a focus for technology education, I began to look for different practices that engineers use as they approach the design process. And one of the tools that I came across that I thought would be excellent fit for technology education was the decision matrix. And so today I hope to kind of feature some of the elements of how you might use a decision matrix, as well as give you a in-class introductory activity that you could do with students that might help orient them to this new approach to making decisions and allow them to practice a little bit before they actually use it with their own designs. So let's take a closer look at this approach. So back in 2006, Dr. Roger Hill suggested that technology education students often really struggle to identify design constraints and criteria, specifically before they enter the stage of selecting a final design idea. How do you make that final decision? And so we know that students often do struggle to make informed decisions about their final ideas. And this is even more challenging when we put students in teams where everybody has their own opinion and they approach it differently. And often we can see that arguments come out. And so I really was trying to look for some sort of systematic approach to help students make decisions. And so when I came across the decision matrix in several of the engineering design textbooks, I thought this would be an excellent way for students to be able to kind of navigate through this process. So let's continue to take a closer look here. So we actually find in the standards for technological literacy, it actually talks about professional engineers engaging in a design process, and often one of the first steps or stages in that process is they really try and identify and address design criteria, and they often have specific constraints imposed upon them or embedded within the engineering design problem. And so engineers are confronted with this idea of constraints and criteria, and I believe that this is something extremely important that we teach our students if we're going to be authentic to teaching them about engineering design approaches. So for this webinar, let's be specific here. We'll tell you specifically some of the things that we're going to try and address during the time that we're working together here. So, after this student lesson that I'm going to share with you, students will be prepared to use a decision matrix when they go to make their final design decisions. So not only is there an in-class activity that I hope to share, we would also expect or hope that they would begin to use a decision matrix when they have brainstormed all sorts of ideas, begin to narrow those ideas down to a few of their best options, and then how do they narrow it down to the final selection. And so this is very important because we want to see that they have a strong rationale for why they select the choice that they do, and this approach will really help them to do this. So first and foremost, I'm going to share with you an overall definition of what is a decision matrix, how it's an engineering design tool. Want to kind of talk a little bit about design constraints versus criteria. Hope to shed a little bit of light on that. Very difficult to make a final definition on those, and I probably won't be able to do that completely and clearly, but I hope to be able to generate a dialogue that you could generate with your students about what might the difference between constraints and criteria be. Kind of a frustrating part of the design process is it seems like there's not really a strong, clear difference between the two, but I hope to share at least some more details. And then we hope to be able to assist students in determining which design ideas are best for them to go and select to be prototyped. And this can be a challenge for teachers. It was definitely a challenge for me when I was working with my students. And a number of years ago, I had a teacher I was working with, actually at the elementary level, say how do you get students to let go of their own idea for the betterment of the team? And so I would hope that this might be one approach that can be used. But in the end of our discussion, we realized that humans are biased in a way, and they all think that their design is the best design. And so I know that teachers will still have a struggle with that, but hopefully this at least gives you one approach, and does give a design team an approach to use to make a final decision. And then I hope to be able to share some examples of a decision matrix and their application for teaching engineering design. So, all right, let's keep going on here. So, back in 2010, the May-June issue of 2010 features this design assessment in-class activity that I called kind of design assessment consumer report style approach to making decisions. And in it, I feature the decision matrix and go into much more detail than I probably would be able to do today, and share some of the literature from those in engineering and also in technology education that support this approach to helping students make decisions. So maybe you can go back and reference this. It did have some suggested handouts and even some elements of a lesson plan that would be helpful for you as well if you plan to do this in your class. So just a reminder to you, I'm not sure if you're familiar with the Consumer Reports issues. Believe they're still available and around today. May not be quite as popular as they once were, because today we have all sorts of online forms of assessment where we go in and we look at customer reviews, and sometimes you can spend hours looking at different opinions of a product and whether this product is a good product or not. And so certainly many of the students today living in this digital age have probably reviewed a lot of consumer reviews and have seen those. What I liked about the Consumer Reports style approach was they had kind of this Likert scale type of approach, from poor to fair to good to excellent. They kind of broke it down in various categories, as you see here, and various products that they were taking a closer look at, and then telling you what the capacities were and where they rank in these various categories, so that a consumer can make a good informed decision about what product might fit them best. And so you might spend a few minutes, you might have a few of these Consumer Reports publications to show students, so at least they have a reference for how this has actually been done in various publications, and done in a formal way. And I think Consumer Reports did a great job of creating a very systematic approach to assessing products. So you might share that with them as well. Okay, let's talk a little bit about design constraints. So I have had more teachers and some colleagues talk to me about design constraints and criteria more than any other topic regarding design. And there's definitely some great confusion there. What's the difference between them? And sometimes I think we make a bigger deal out of this maybe than it really is. So I'll try and attempt to bring some clarity maybe to this, or at least add to the discussion, because I don't think there's an easy answer here. And surprisingly, there is not a lot in the literature regarding the distinction between constraints and criteria. So for constraints, I think it's a little easier. I think we have a better understanding of this than we have of design criteria. But constraints are those limitations that we place on a design solution. And here's some typical ones. Now, I mentioned, I caution you that these could become criteria, and I'm going to give you an example of that here in a minute of one of these items that's on our list here. So oftentimes it might be the size of the product, might be the overall cost of it, could be the weight or capacity of this. I think this one's key. Addressing specific regulations. There might be governmental regulations on a product. There may be specific things you must abide by such as a building code, and that you have to meet those codes in order to have a successful design solution or a successful product. That one's extremely important. That clearly is a constraint. It clearly is a limitation. It is something that you must be held accountable to. And so those are definitely strong examples, I believe, of constraints. Time, actually. I've never really known of any designer just having unlimited time to design something. Often, if they're a professional designer, they have a time, a turnaround time to complete the project. And so you do the same thing with students. You impose a constraint upon the students because you're asking them to complete something in a certain amount of time. You're asking them to create a design solution. Has to be done at a certain point in the school year. And so probably the most complained about element often of design is that there's not enough time. Seems there's not enough time, not enough money, and those are definitely constraints that we have. And then your resources. So if we're building something, we're creating something, and we are in a developing country, we may have limited resources, and that will be a constraint imposed upon the design team, saying you'll be building it here, and you may only have these materials to work with. We also do this when we do design activities in our classroom, and we may identify a specific constraint inside a design brief because we're telling them they can only use set materials, only these materials, or maybe we even limit the number of those materials that they're given. So we as teachers, when we assign a design task or a design challenge, we often do a good job of defining what these specific constraints are. And so we actually provide a good example, I think, for students to reference as they're trying to understand, well, what really are the constraints of this design problem. Sometimes those are very crisp and well defined, and then as students continue to improve their experiences in the design process, then we're going to allow them to start defining what are those constraints and giving them a little bit more room and giving a little more ambiguity to design challenges, and they become more open-ended, more ill-defined, and more authentic in design challenges. And so I think that's something extremely important to understand, is that teachers will purposefully define them in the early stages of their learning of the design process, and as time goes on, let's say to a capstone experience, it may be very ill-defined and the student is taking that on. It's very student-centered. They're defining these things themselves, and this will be a key area. Having students have the ability to think through what are important constraints that I as a designer will want to impose on this problem is very important, an important part of the process, and a key piece to the learning process of learning design as we move forward. So design criteria is similar, and yet there's confusion between the two because sometimes constraints become criteria, and let's take a closer look at that. So design criteria is most often defined by a client. So if a client is hiring a professional designer or a professional engineer to create something, they're going to most often be very clear in the things that they want, the desired features of a design solution, and they might describe those to somebody. Sometimes the end user, the consumer of this product, will be demanding specific unique features of that design solution. And then as we put them out on the market and we see consumers selecting certain products over others, that's when the real demand becomes, and that's when clients usually often come back and say, now we must have this key feature because now our customer is expecting this key feature in the design solution. One example might be a client might specifically come to a designer or design team and specifically say, I want this thing to cost less than $10. This must be less than $10 for this final design solution. And I believe at that point it goes from just kind of a constraint to a specific desired feature. This is something that we are going to keep an eye on as we design our final solution, because we know the client is really demanding that we address this one. It's a desired feature of the final design solution. So again, I kind of tried to somewhat define criteria by really thinking about this desired feature that the client has identified. And then, like I mentioned before, the end user. I think a perfect example of this, a great example that we've had, our most recent technology history, is take a look at the artifact of a cell phone, and showing students some examples of early cell phones. You think about these old cell phones that came with a carrying case and a box, all the way to a flip phone. And so over time, the consumer demanded this design criteria. They said that we desire that the cell phone can fit in our pocket. And so they continue to get smaller and smaller to the eventual flip phone, where it hinged in the center so that this would collapse and be compact and fit in your pocket without a problem. What's interesting about this type of technology is over time the purpose of the technology has also changed. So instead of a cell phone being a phone, we now see a cell phone having many other criteria or features that the client and the end users were demanding. So it went from being just a normal cell phone to be able to phone somebody, to now being a small computer that you're going to be able to use. And so what has actually happened in this type of technology is now it's gone back. It's increased in size because of the screen capacities, the touch screen capacities, and the idea that you're using a cell phone not so much as a phone, but as a computer system. And so because that is a new feature within cell phones, it changed how people are designing that phone. And so I think that's a great example to share with students. Although size can be a constraint, it also can be a criteria, and that the end user, the customer, eventually how they use it will also define that criteria as that product continues to evolve over time. So it'd be very interesting to take a closer look at that, how smaller and smaller it got, and now how it's getting larger and larger, because the actual purpose of that product and the use of that product has changed over time. And so I hope that might help students at least have a discussion with you about what is the difference between criteria and constraint. Okay, a decision matrix. What is a decision matrix? So specifically, this is a design tool that enables a fair comparison of alternative designs to help determine the best solution under current conditions. And so I really like that definition. I think it's pretty clear. It will really help us have a fair comparison across these different design criteria and constraints. This procedure allows design team members to have equal input into a final design decision. So, decision matrix is great if you're developing this design idea on your own. It's even more important when you're working with others in a team. And so I really would challenge and encourage teachers, if they have students working in design teams, to really consider using a decision matrix with their students, teaching them first, using this activity I'm going to share, but then requiring that they put this in their engineer's notebook. How did the team arrive at the final design solution? And often in my classes, we have the students present this at the end of their design class in the final presentation, to really share with everybody in the room, this is the process we took, these are the decisions that we made, this is how we've arrived at our final solution, and it really provides a key rationale to the final stages of the design process. So I believe this is an extremely important tool. Now, in order to do this, to create a decision matrix, we first have to determine constraints and criteria. So it may be after students are brainstorming many ideas and then they define or even redefine the problem. And that's very important. Oftentimes we need to go out and talk to potential end users. We need to make sure that we're talking to our client that is working with us. If you don't have students doing those kind of things, you might consider having them identify who might be a potential client for whatever it is that they're designing or creating, and then also go and do some interviewing and maybe some observations with potential end users. What are they using now? And I think that helps them determine what are the necessary constraints and criteria for this final product. Hopefully they're doing that in that problem scoping phase of the process, which I think is very, very important, that students kind of explore all of that. Okay, so here I'm going to get into the very specific student design challenge or class activity that I would have students do. So I would encourage teachers to challenge their students to bring in 3 similar products. So maybe 3 different commercially made product of some type. I'm throwing up just a couple of examples here, such as the wallet. I've seen people use a purse or bags that they have, an umbrella, something like that that's easy to bring into the classroom. Um, you know, Backpacks are easy because oftentimes students might be bringing those things to school or bringing them even into the classroom. When I've done this with teachers in the past in professional development, travel mugs are a pretty good item to practice on, because many of us use these. They're pretty accessible. You could even go to a store and buy them just for this design activity, put them in a box and have them available to pull out. Student water bottles often is an example as well that I've seen people use. I really would encourage people to avoid electronic technology, because sometimes there's so many features embedded within a specific technology that it may get really confusing quickly for a student. So you might want to think about everyday objects that are around them all the time that they use on a regular basis. And again, I'd encourage you to pose that to the students and get them to brainstorm what would be the best products to do this consumer report analysis on, and see what they come up with. So the first thing that we would have them do is collect technical information. And I love this part because, again, a piece of this is about technical writing. When you look at a product, or you look at how a product is described, if this is being sold online, how does the vendor describe that specific product? And so encourage students to take a look at some of those examples, and then as they have the product in front of them, can they describe it in a similar way? And so this team needs to gather as much technical information about this as possible. This information might include a physical description, such as size and shape and color and capacity. What I love here is, if you get the right objects, this is where you can teach students how to use dial calipers, just even simply more practice reading a ruler, which many times people tell me students need as much practice as they possibly can get of using a ruler. All right, how do I go about measuring this specific object? What angles do I need to take? Where am I going to take these measurements? And then how is that described? So even the three-dimensional elements of a top, front, right side orientation is a great opportunity to describe that and talk to students about how they would describe it and describe those features to someone else who might not have the object right in front of them. So very useful practice, I believe. So obviously, any technical description that we can provide to somebody, I would encourage students to write those things down. Do this in an engineer's notebook. We also have handouts that I did provide in that article. And so you would have students lay that all out and write those out either on a worksheet, or, again, like I mentioned, I think it's good practice to do right in an engineer's notebook. And then they also are going to need to describe any of these unique features that come in this design solution. So this might include a picture or a sketch. Oftentimes I use this to have students practice their technical sketching. And so you could really draw this activity out. It could actually be several day type in-class activity, depending on how detailed you want the students to get as they sketch this thing and describe it, and then tell about the unique features about that object. Okay, the next step in the process is for the students to come back together after they've kind of looked at an individual product, and they need to share the information with a group and really discuss each design. And then that allows every student to kind of react about each other of the designs of the products. And that really build this conversation about, if they were to purchase this particular product, what would be the most important features? What would be the things they would be looking for as they would be selecting that as a consumer? And then here is where the kind of their overall values begin to flesh out. What is it that they are looking for in this great product? And hopefully they'll begin to identify what those key features are. That they also might be able to identify, are there special regulations on this product? Does it have to abide by certain codes? Are there some limitations to this product? And oftentimes safety comes in as a key feature of this. This is the reason why we have these regulations often, is to be safe for the public, right? And so is this one of those products that we have to be careful how it's used? and who is using it, and then is it done so safely. So hopefully they have this great discussion about, well, when they go to purchase a product like this, what are they looking for in this type of product? And that's when you begin to get them to list out all the constraints and criteria and start to put a value to each of those. Now, we'd like these to be percentages of the overall ratings. So get them to really think about totaling this up to be 100. And I think this is often where the dialogue really begins with students, and really kind of this negotiating back and forth between what really is of most importance. And they may not be able to come to a consensus right away. They may have to actually really kind of work through that and think through, all right, what's the best compromise for us as a team? And again, this is a soft skill. This is a critical skill. This is a 21st century skill, and yet it's very important, I think, as students work in teams, is to think about what is their value structure of these things, and those values might be different for other people, and that's okay. Can we come up with a universal standard for these things? And it's kind of neat because oftentimes students will come back and they'll realize what I just did there was I reverse engineered, I reverse assessed a design product by looking at it as a final solution. But really kind of when I'm done, I can think about how the designer came up with the features they came up with and why they came up with them. Because these are the ways in which we interact with this type of technology, and we want it to be user friendly, and we want it to be at a decent cost and a good value. And so just this is almost from a consumer side of things, they're looking at this and evaluating things. It's another type of technological literacy, so it's very important. Okay, so let's see what this looks like in more detail as we look at a decision matrix and as we look at a specific example. Okay, so my favorite example of a product to take a closer look at is one that obviously comes up in schools or is used in schools, and not only for students but for teachers and faculty members. Is a backpack. And so I really like this example because this is a common everyday artifact. Most everyone uses a backpack or have used a backpack in the past, so it's something that I think everybody can relate to. And by the way, is the example that I used in that article back in 2010, and really kind of walked through those examples of 3 specific backpacks and then how students might fill out a decision matrix. So we're actually going to do that again right here. And so when I've done this in the past and I've worked with people, we've had this discussion of these various products. You hold them up, you look at them, you look in them, you see how they function, how they fit. You might even consider that students, and I even propose this, that students would load this thing up either with some weights or with some books and see about its comfort as you wear it and use it, and actually kind of go through the motions of using that product the way it's intended to be used and see how well it performs. And so sometimes we have students do that. The teams that I've been in, often some of the key features that came up were these. It was functionality. Did this thing, did it perform the way you expected a backpack to perform? Was it comfortable? That was a second kind of key feature. Another one, of course, was aesthetics. Is this attractive? Is this something that I want to carry and use every day and see every day? Is this appealing to me? So aesthetics was the third. A fourth category that came up was durability. Is this thing going to last over time, or is this only going to be a 1 year and done, or 6 months and done type of a product? So those were some key criteria that we identified by just kind of looking at different backpacks. Your students might have come up with something different. They may come up with a huge long laundry list of different criteria, and I would encourage and have you challenge students to narrow those down to probably 4 or 5. And then can they look at some other things that might be some constraints? So for us, constraints were cost and size, or capacity. And so we listed those as our constraints in this specific example. So next I want to show you what that looks like when we start to put those features in a decision matrix and when we start to discuss value structure to them. So we'll look at that on this next slide. Okay, so here's an example of a decision matrix. You can lay these out in many different ways. I really like and highly encourage the use of this unique approach, especially with a little triangular formation here, and we'll talk about that in a little bit. I think this even adds to the ability of a decision matrix to be just a great tool to be fair in terms of the evaluation, and I'll explain why as we move forward. And really it comes down to this weighting of things. So you rank things and then you apply the weight, and we'll show the example of that. So you can see here, I actually list these out, and I do this in a hierarchical order, and you'll see that here in a few minutes when we actually put the weight percentages in. But again, as I mentioned before, I had functionality, comfort, aesthetics, durability, and then cost and size. Now, before students actually fill this out, you may talk about each of those categories, even getting students to really be sure that we all are on the same page. What do we mean when we use the word functionality, right? So you might have them describe that. And again, another technical writing opportunity for them. Here's what we mean when we use this term. When we use the term comfort, well, what specifically does it mean? Is this a fully loaded backpack? Are we looking for a lumbar support? Those kind of things, as we look for the unique features of the backpack. So again, still more dialogue that's taking place, and then you're going to place a weight on this. And there's a great example that we're providing for you that really it came down to functionality. Did this thing have enough pockets to it, and that I can easily access the books or whatever is inside of that backpack? Does it have enough features so that everything is secured within this bag? Those were overall kind of definition of functionality. That was our most important. Comfort was next. And so it really mattered to our team that this thing was going to be comfortable for the students, especially if they're carrying huge number of books back and forth to school on a regular basis. Comfort was important. Then aesthetics, and then durability, and then cost in this particular case, and size. Our constraints were even at 10%. And so again, very important to have students make sure that it all adds up to 100 total points for the weighting, and then that obviously is our percentages to all these key features. And then from there, students need to look those over and independently rate these various 3 designs. And so let's say students go ahead and do that, and then they rate them on a Likert. Remember, we had the Likert scale being 5 being the best and 1 being the most poor or the limited design solution, and then go ahead and rank those in that kind of triangular section on the right hand side. So they go ahead and rate those. You'd fill the same in for design 2 and design 3, and then you take that number. So for example, here in our first design, number 1 design solution, that 5 is multiplied by the 30, coming up with 150, and you do that in all the categories, and then you total that up. And the point that I'd like to make here about this type of decision matrix that I really like is sometimes it can be a little deceiving in the fact that some of the categories design solution might perform extremely well, but yet it doesn't perform as well in the features that we have weighted the greatest, right? So if, may do really well in overall cost, and the overall capacity or size is fine, durability is fine, but functionality is not, then that in the end, oftentimes, it will work itself out in this decision matrix, the way that you're creating it. That sometimes you're surprised at your final solutions, and I think that's, or your final answers. I think that's a good thing. I think it's great actually when students may be a little biased. They may be filling things out and they're not realizing that boy, aesthetics was really important to them, and they're rating the most beautiful one obviously a 5, and then the others they give them a 1 because they didn't think it looked all that great. But then the rest of the team rates the other more weighted categories higher, and then these other designs win out. And so I think it was good at being just a systematic approach to making that final decision. And so hopefully this makes sense. Use this as an example. I would share this with your students. I really encourage the weighting, and I really like the triangular approach there, where it's at the very last stage when they add these total points up, and I think that will help. Now you'll have some students that are smart enough to run the numbers ahead of time and say, well, I'm going to make sure that mine wins. But at least it's a great attempt at helping students to make these decisions, to do it corporately, to do it in a team, to have these dialogues of what's going to be most important to us and what are we going to value, and then that helps them to make their final design decision. And I really would encourage and stress that you should have students put this in an engineer's notebook, and most importantly, it needs to be featured in the final design solution PowerPoint presentation, or your presentation at the end of your assignment for students, because it shows a great rationale of why did they select the design that they chose to prototype. What led them to that final decision? This is a great way for students to show a rationale. This is how I came to this final product idea. So again, I hope this helps. I hope this example would help you in the classroom, that you can use this with your students, that you can assign this simple analyzing 3 existing products. Then they learn the decision matrix, then they use it again later when they create their own designs. So in that engineer's notebook, you might see a brainstorm session of many different design sketches, many different ideas generated, and then they have to narrow it down to a few, and those few get loaded into this decision matrix so that they can make their best, most informed, most addressing the client's needs and the end user's needs, and that they do so in a very systematic and a purposeful way. And so again, I hope this has helped as we continue to try and encourage students to learn the engineering design process. And again, I think this is an authentic practice that engineers are using as they make their final design decisions. Thank you very much. My name again is Todd Kelly, and appreciate the opportunity to share this information with you. Goodbye.